So hello everyone. So today's problem is set matrix zeros. So given a m cross an integer matrix, if an element is zero, set it in entire row and column as zero. You have to do it at inverse. Please like, share, and subscribe to my channel. So we'll go through the test cases to understand the problem statement better. So this is the input array. You have to give this particular output. So as you can see, this is the element which is zero. So you have to make the entire row as well as the entire column as zero. So that is what we have to return. So in this particular input, there are two values which are non-zero, which are zeros. So you have to make this column as zero and this row as zero. For this particular index, you have to make this column zero and this row zero. So as you can see, we have to return that output. In this, the third test case, there is no zero, so we have to return this matrix itself. So there are three approaches for this particular question, which is brute force, better, and optimal. So we'll go through all three. First, we'll go through brute force. So this is the input array. So let's go through the algorithm first, and I'll do the dry run. So we have to make an extra array here. So we have to make a results array, which is an extra n cross m space complexity. So let's go through the algorithm. So go through every index in the matrix. You have to go through every index and check for that corresponding coordinate if we have zero in either row or column. So we have to go through every index. So suppose we are at this particular index, we have to go through the entire row to check if it's if any of the value in this row is zero, and we have to go through the entire column to check whether any of the value in this column is zero. So for this particular index, as you can see, there are no zeros in the row as well as in column. So we'll mark it. What it is. So in this particular index, we can see that in the column we have a zero, so we have to mark zero. In this, the entire row as well as column is non-zero, so we have to mark what it is. Here, as you can see, in the row it's zero, so you have to mark zero. This is zero, so itself, and this is one, and the row we have a zero, so we'll mark it zero. So one, as you can see, there is no zero in the row as well as in column, so we'll mark one. Here, as you can see, in the column zero is present, so we'll mark zero. And here in the column non-zero elements and the row also non-zero elements. So we'll mark what it is. So this is the desired output. As you can see, this is the code for the same. We have to go through every element. First, we'll create a same input, an external array with the same size as the input array. So we'll go through every index from 0 to n, 0 to m. So we'll check if we have 0 in either the column or in the row. So if we have a zero, we'll make zero present, which means that we have found a zero either in a row or the column for that particular index. So if we see that we have a zero, so I'll mark that zero, that particular index, I'll mark it zero, else I'll keep it what it is. So this is the brute force. As you can see, we are using three loops, this for loops and this the internal for loop. So we are using two internal for loops. So the time complexity is big O of n square, which is going through every index into n plus n, because we are going through two internal for loops for checking if the column or the row has zero. So if we consider this n plus n as 2n, this would be 2n cube, 2n cube, and it's approximately n cube. So n cube will be accepted because it's the value of n is 2 power 2 into 10 power 2. If you do the n cube for it, it would be 8 into 10 power 6. So it will be accepted as it is less than 10 power 8. But we can do better. So let's go for the better approach. The space complexity is very good here, but the time is very inefficient. So we'll go through the better approach. So let's go through the algorithm first. So we'll make two Boolean arrays which will help us identify if a particular row or column has zeros. So here we were manually going through every row and column for every index to check if that row or column contains zero. So here, instead of that, we are taking external arrays, external Boolean arrays to figure that out. Second, the step is check every index in the matrix. If found zero, make it respective row and column as true. So this and this are Boolean arrays. So if we find any element which is zero, we'll mark its corresponding row and corresponding row and corresponding column as true. So we'll go through that first. We'll update this Boolean arrays, then we'll go to the third step. So this is non-zero, so we'll not mark anything. This is non-zero, so we won't mark anything. Same for this. This is non-zero, this is zero. So we have to mark this true as well as this true. This is non-zero, this is non-zero, this is non-zero. So initialize with false. Everyone will be initialized with false. As this has a zero, we'll mark that column as well as that row as true. So we'll see the third step. What is the third step? If either row or column contains zero, so either row or column contains zero, which is true, make that value as zero. So if this value is true and this value is true, we'll mark that particular coordinate as zero. So we'll go through the code once. We'll make two Boolean arrays, rows and columns. We'll go through every index in the matrix, input matrix. If it's zero, we'll mark that particular row and that particular column as true. After that, we'll again go through every element in the matrix because we have to change the element, change the matrix according to the questions, which is that we have to make the entire row and column as zero. So we'll check for every index, we'll check if the row of that particular index and column for every particular index of that particular index is zero, which means either if this is true or this is true or both are true, then we make that index as zero. Otherwise, we don't change it to zero. So if you see, the time complexity is n square because we are using two for loops, and this is the best time complexity that we can get from this particular question. Space complexity is max of length of the row array or the column array. So this is the extra space we are using. So in the brute force we had n cube. In this we have n square, but we have an extra space here. So in the optimal approach, we'll try to remove this. We cannot optimize this further, so we have to remove this particular space complexity. So we'll go to optimal approach. So for the optimal approach, we'll go through the algorithm first, then I'll do a try run, then we'll see the code. So first step is go through every element. If found zero, make it corresponding first row and column zero in the matrix itself. So we'll do the first step. So I'll take a different color. So we have to go through every index, and if it's non-zero, if it's zero, then we have to mark its corresponding first row and first column as zero. So this is zero, so we'll mark this as zero. This is one, so mark one, keep it as it is. This is two, this is zero, this is three, this is four, non-zero, zero. So this is zero, so we have to mark that particular column as well as the row zero. Okay, this is non-zero, this is non-zero, so we'll keep it. This is non-zero, this is non-zero, this is non-zero, this is 8, this is non-zero, this is non-zero, this is non-zero. So this is our matrix after first step. This all rest of the values will be the same. The second step is leaving the first row and the column, that is starting from 1 comma 1. Check for each index if its corresponding row or column is 0. If yes, make it 0. So for rest of the indexes which is starting from 1 comma 1, so the smaller 3 comma 3 matrix, we have to check whether its corresponding column or the row contains 0. If either one is 0, they'll mark it 0. Otherwise, if we keep it what it is. So let's do the second step. This is 0. I'll not change the first one, the first column for this step. This is 4. This is non-zero. This is 0. So we have to mark this 0. So 0. So it's 0. 2. So row and column is 0. So we mark it 0. So 3. Both are non-zero. So we mark it 3. 1. The column is 0. So we mark it 0. 5. The column is 0. 7. Both are non-zero. So we mark it 7. 0. The column is 0. So we mark it 0. 9. The column is 0. So we mark it 0. The second step is done. So we'll go through third step. Check if the first row and the first column contains 0. After doing the second step, we'll check the first row and the first column. If first row contains 0, we have to make the complete row 0. And if the first column contains 0, we have to make the complete column 0. So now we'll go through the code. We'll make two variables, first row and first column, which will indicate whether we have a 0 in the first row and a 0 in the first column. So we'll go through every element as stated in the first uh, point. We'll go through every index. We'll check if the row is 0, so we'll mark this particular value as true. If the column is 0, we'll mark first column as true, and we'll mark that corresponding row and that corresponding column as 0. So for this we'll mark this as 0. So this is what these two steps are saying. Then after the first step is done, we have to go to the smaller matrix, which is starting from 1 comma 1. We have to check whether the row or the column contains 0. If either one is true, we have to mark that particular index as 0. So if you can see, for this value, the, the row is 0, so we marked it 0. For this particular value, you can see this both are non-zero, so we marked it what it is. So it was 3, so we marked 3. So we only change if either the row or the column is 0, we change it then only. Otherwise, we don't change. After that, we have to check if the first row or the first column is 0. If the first row is 0, we make the complete first row 0. If the first column is 0, contains 0, sorry. If the first row contains 0, we have to make the entire row 0. If the first column contains 0, we have to make the entire column 0. So I hope you understand the optimal approach. Let's see the time and space complexity for this. Uh, the time is n square because we are going through every index in the matrix, and space is O of 1 because we are not using any external space. We are utilizing the matrix itself as the Boolean array, as we have seen in the better approach. Instead of using external spaces, we are using the matrix itself as the Boolean array. Hope you understand, and like, share, and subscribe to my channel. It is motivating, and please, if you have any suggestions, please note comment it down. I'll read it and try it out. Thank you.